Over time, operating procedures can become disjointed as stopgaps are created to resolve one threat after another. Here to address this subject is our next panel, which will be moderated by Captain Helena Cunningham, who is ALPA's Human Factors and Training subject matter expert and flies for Delta Airlines. Thank you, Helena, and we look forward to hearing from you and your distinguished panel.
And good morning, ladies and gentlemen. I am so excited today to moderate this panel on human-centered operating principles. It's been a personal project, passion project of mine for several years, and I couldn't think of a better panel to follow than Lija's on resilience. So without further ado, let's talk about the impressive lineup we have here today, and I'm certain that you'll find the discussion both interesting and relevant and most likely riveting as well. For those of you who attended last year's Air Safety Forum's panel on titled We Can and Must Improve Human-Centered Operating Principles and Procedures, that panel discussed why we need more human-centered policies and procedures. Panelists cited accidents where procedures and checklists were found contributing. It was pointed out that often over time, modification after modification to policies and procedures, they can become disjointed and not work well within human strengths and weaknesses. So, for example, flaps not set before takeoff has been and remains a repetitive problem in airline operations. Simply having it on a checklist has not prevented fatal accidents. Cueing and anchoring is a behavioral conditioning technique that connects a stimulus to a trained response. It's a design that's human-centric. By simply using strong, reliable memory cues, then anchoring the action request to a priority item, that's part of our most powerful habit patterns, like the flows. An anchoring example would be the before taxi checklist call out. Set flaps 5 before taxi checklist. When properly cued, this type of approach can be useful in mitigating errors throughout the operating system, and particularly important with critical items. This panel will focus on how to help airlines develop operating policies and procedures that are human-centered. Today, we'll discuss how we can make the operation better and more resilient for our pilots. So let's meet our distinguished panel. Captain Steve Guillian. He spent recently 5 years as the Threat and Error Management Project Coordinator for JetBlue Airways and has several decades of procedures development experience. And then we have Captain Ben Berman, co-author of The Limits of Expertise, one of my favorites, Rethinking Pilot Error and Causes of Airline Accidents. And finally, Dr. Immanuel Barshi, a frequent contributor to our panels. And as I like to say, the gift that keeps on giving. Senior Principal Investigator at the Human System Integration Division, NASA Ames Research Center. So quite a distinguished lineup. Let's start with Steve. Captain Guillian, would you mind telling us what you've been doing at JetBlue Airways to make policies and procedures more human-centered?
Thanks, Helena, and thanks, ALPA, for creating this. Before I roll into what I want to say, I think most people in here are familiar with the 4 Ps, but just a baseline. The 4 Ps are a set of ideas that are interrelated. They're also a set of, it's a policy, it's a procedure development practice. Those ideas are philosophy, policy, procedure, and practice. Now, when I think about human-centered operating principles, I think about human performance or human resilience. I think about automation, and I think about the 4 Ps. I think about those things as interrelated, and I think that in order to talk about them in a comprehensive way, you have to talk about them all with equal interest and energy. At JetBlue, we came to human-centered operating principles. We pursued them along a bunch of different pathways. So I'm going to talk about 6 pathways. The 5 that we implemented and a 6 that we stopped short on. I think stopping short is actually just as instructive for the group as things where we made some success. Okay, the first angle that we took a long time ago is that we built a foundational, serious as a heart attack, this is what your check airman cares about, this is what will keep you out of trouble training course. It was essentially a training course on resiliency. The goal was that all of our pilots would understand the second law of thermodynamics, which in aviation is that the world is full of threats, human beings make errors, and that all of this is perfectly normal, right? And to focus on those things and the idea that there's things pilots do every day to prevent, trap, and mitigate off-nominal conditions. So creating this course, the process of creating this course helped us to move from a concept of perfect to a concept of resilient, where resilient means using adequate defenses relative to the operational complexity that you encounter. It also helped us to subsume technical and procedural ideas with human performance ideas, right? So a lot of the defenses that pilots use to be resilient are supplied by the airline. Procedures, standards, automation. This course was successful. It achieved its goal. So what did it take to do that? This project was highly managed. All right, so in the context of an airline JetBlue size, that meant this course was delivered by one single instructor for 13 years, only 2 alternates, so that we were able to deliver the same controlled product to every pilot at JetBlue. The next angle, following immediately from that, was we built our AQP grading system in a human performance centered way, right? What do I mean by that? Evaluators and instructors were evaluating the adequacy of the defenses used. And not just scoring it, but grabbing lots of narrative data for us, right? And then the narrative data is the data that was the most useful for us in driving where we needed to go. But I do want to say that there's very big differences in the quality of narrative data that we got, so from great to maybe not so good to maybe completely absent, right? And I'll come back to this later. The next angle that we pursued was we expanded that training program to make it both human-centered and flight path-centered, right? So we identified several training items that improve how humans team with automation. The first one was to look at the strategic task management and task distribution. We looked at fine-grained workload management and task distribution, and we also looked at attentional feedback. Now, things that are easy to master are things that are high feedback. But pilot scan sample rate feels notoriously low feedback. But there are things in the operational environment, things out there in nature, that we can draw pilots' attention to and attach meaning to so that our pilots' awareness of their scan sample rate becomes higher feedback, and they're better able to master it. Now, of course, I'm talking about when the airplane's automated. It's a lot easier when we're doing manual handling, which was another big realization, that the mental muscle that we use to monitor a flight path when the aircraft has the autopilot on is built when we're manual handling. And we realize that the collective effect of a lot of our communications was to discourage manual handling, right? So we had to, as part of this project, turn that around and encourage manual handling and make it really clear why we were doing that. The next pathway or angle that we followed was we used a 4P process to course correct the human-centeredness of our policies and procedures so that they'd be more effective. After our third LOSA, we noticed that our procedural compliance was, to put it nicely, trending the wrong way. We had FOQA data that was showing that our marginal flight states attributed to those procedures were trending the wrong way. To Helena's point, we were getting within 100 yards of the takeoff runway with flaps not set once a day. We needed better procedures. We had procedures that were linearizing things that just don't happen in a linear fashion. We needed procedures that match the natural way of doing things. Sometimes we just needed to back off the procedure and orient ourselves off a principle that was built off of the how and the why, like briefings. To do this, the 4P process, we put together a very disciplined, smart team. We gave them resources and we gave them time. And they spent most of their time building a philosophy manual, not just a couple pages, a manual. This manual could have been called the Human Principled Operating Manual. No, it was the philosophy manual that we're going to build our policies and procedures off of. We then reviewed all our policy procedures from the perspective of this manual. This resulted in a major streamlining. It was well received by the pilots. It resulted in an instantaneous and sustained improvement in all the things that I mentioned, measured with FOQA data. The next angle or pathway that we pursued was to migrate our human-centered operating principles to dispatch, tech ops, ground ops, and in-flight in order to identify the workgroup specific resiliency skills specific to those jobs. All right, I think the process will be interesting to you guys. We started with interviews. We interviewed supervisors about what differentiated high-performing employees, very resilient crew members. We interviewed high performers and tried to ask them smart questions, like what's the difference in the way that you handle this situation versus the way that a lower performer or novice person would. We paid a lot of attention to as much of the academic literature as we could, and we looked for where all those areas overlapped. Whenever we felt like we were over-interpreting the academic literature, we just reached out to the academic community. They were very helpful. The next step in that process was to collaborate with those work groups to build introductory, applied, and recurrent training. The thing I wanted to mention here that I thought you would appreciate is that involved a lot of, the applied training involved a lot of scenario-based training. Okay, so the nugget I want to leave you with is that in building scenario-based training, the advice we got was keep them simple. It turns out, when you keep it simple, the scenarios are a lot easier to build, and the product is a lot better. The scenario-based training, the scenarios actually work better when you don't make them too complicated. The last angle I want to talk about, this is the one where we really just hit so much inertia that it never happened. We looked into the creation of instructor development training that would enable flight instructors to coach basic human performance principles. All right, now there's really differences in ability between pilots. And there's differences in ability, probably more so, between instructor pilots. Oftentimes when instructor pilots retrain, they use the toolkit of procedures training to address what's really an underlying human resiliency or human performance problem, because that's the only toolkit that we give them. Our instructor development training was going to be targeted to coach what we thought were the really big difference items. For example, sometimes when we mismanage a situation, it's because we got the action script wrong, right? But maybe more often, it's because other parts of our mental model were incomplete. And so some of the big differences in ability between pilots is, what are they including in their mental model? Managing changing or competing goals, neglected assumptions or valid conditions, knowing what to expect, understanding the gotchas or how not to do it wrong. We thought we'd get a lot of bang for our buck in terms of the quality of instruction that we'd get with this, but we really thought we'd get an even bigger bang for our buck in the quality of narrative descriptions that we'd get back from the instructors and evaluators into the AQP database. We thought we'd make that data a lot more, the narrative is a lot more rich and consistently rich. All right, now, to the extent that we were successful in these pathways or initiatives, the common theme was extreme discipline at every step of the way. To the extent we lost momentum, it's because we failed to appreciate the fact that what was at some point, you start to force transformational change in the organization, and the inertia just gets huge. Training centers are geared for procedural training. Focusing on human resiliency training or human performance training and associated instructor development starts to look like transformational change a lot faster than we anticipated. There's also industry limitations. Regulatory word count matters. The word count on procedure and technical training dwarfs the word count on any kind of human performance training. All right, so why should we increase our focus on applied human performance or applied human resiliency training? It's hard, it's not required, it's expensive to deliver, it places new burdens on instructor development training, and even pushes down on hiring qualifications. What I mean by that is, in the schoolhouse, who are you going to hire to be, who are we hiring now, and who do we need to hire if we're going to train at this level? Right now, you know, the industry's pretty safe. Human performance is really pretty good. We don't have a dramatic crisis happening, but I would argue we have a slow, insidious problem. It's not the kind of problem that you run into. It's the kind of problem that you realize you created way after it's too late to course correct for it. Human resilience, human performance is an important component of human-centered operating principles, and it's not keeping pace with development of automation and procedural development. The work of building applied human resilience training or human performance training is where you gain the explanatory depth that you need to build human performance into our operational philosophies and our operational philosophy manuals, right? If the role of human resilience or human performance isn't clear in your operating philosophy, then your policies and procedures will suffer. But it's hard. From inside of an organization, we found we just couldn't do it. There was just too much inertia. We were working at the wrong scale. So how do we do it then? How do we do good stuff in an affordable way? I'd like some of you to look out there at a consortium in the oil industry called Abnormal Situation Management Consortium. All right, the oil and gas industry understands that safety is not a competitive basis. And they've built consortiums to pool all the resources, like the resources you guys have pulled together here. An airline consortium would pool expertise, money, simulator time, and partnership with research and academic institutions, provide us with grad students to validate and prove that the things that we want to do work. And this would be a problem-solving group, right? Not an interest representation group. The key to success would be to start small. Pick a single project or two, gain confidence, let the airlines gain confidence in the efficacy of the idea and that they're getting good return for their money, and then grow it out as we succeed. Thank you for your time.
Thank you, Captain Guillian. That was fascinating. I'm so impressed with the visionary project you undertook there at JetBlue Airways, and particularly interested in the Abnormal Situation Management Consortium. If anybody is interested, I would suggest engaging with Steve afterwards. I think that's a noble idea. So moving right along, Captain Berman, could you please give us an idea how to identify problem areas of where policies and procedures are not human-centered?
Sure, be glad to try that out. First of all, good morning, everybody. I'd like to thank Airline Pilot Association for drawing us all together, and thank Helena for drawing this panel together so well. Like all of us, when I start out a flight segment, a 3 or 4 day trip with a first officer, I probably never met the person before, or maybe flown with them once, but probably not ever before. I may never fly with them again. We have so many pilots. So we got to find some way of forming our crew unit and breaking the ice. And I usually start out by saying, well, I've never done a perfect flight, although I'm always trying, and I'm going to prove it again shortly. So let me know when I mess up. And the reason I do that, of course, is it's true. I'm going to do that. And the other reason is I want to encourage them to speak up and open the channel of communication. I think it helps a little bit. And that's the way it has to go, because we aren't perfect, and we got to try and be as perfect as we can be, but we can never really achieve it. All in all, we're so good, almost perfect. But if that's not good enough, what we can do as individuals to achieve what we got to do, the public demands that we be 99.99999% perfect. How do we do that, and how have we done it lately? Well, we achieve it as a system, and that includes all the external resources, the automation and the machines and everything like that are working to keep things moving in the right direction, and also especially with the 2 crew members in the front working together, flying and monitoring as the biggest functions. So that's the key to what we do, and so I just want to spend a couple of minutes on why we're not perfect. Why can't I ever do that perfect flight? And we've talked about this already today a little bit, but basically, in terms of what we can't do perfectly, we can't multitask. We just don't do it. Our brains aren't wired that way. Instead, we switch rapidly from one task to the next, very, very quickly, and go from one to the other. And so when we're doing that, the amount of attention we can devote and the rapidity in which we can switch and accuracy is limited. And that can all get overwhelmed with high workload and get overwhelmed with stress and other factors as well. And we're also wired in a way that makes us vulnerable to a whole number of cognitive biases that have become famous in recent years from bestsellers. But basically, we only see what we're expecting to see. We don't recognize what we're not expecting, so we'll miss that. It's hard for us to change plans once we get locked into them. We have all these factors that are making life difficult for us that are built into our brains. We're particularly not so good at the task of monitoring, which of course is one of the key tasks we have here. So when things get very routine for a long time, we can let our guard down a little bit without meaning to. And just on the other hand, when things get very, very busy and high workload spikes, then it's often true that monitoring is the first thing to go, because our brains lock into the more active tasks, the flying or communicating or trying to pull out something. And so the monitoring, which is the thing that's going to catch the next problem or the thing that's getting worse, is often the first thing to go. We base all of our perceptions, what our brains start to make of the external environment, and all of our interpretations of that, and also all of our reactions and actions. We base that all on the information that we get. And so basically, one of the things I want to go into a little more in a couple minutes is that basically it's like garbage in, garbage out. The quality of the information we get is going to pretty much determine what we do. When we're short of time and we're under stress, we can't really thoroughly, deliberately assess the situation. And we had in the previous panel a discussion of the recognition prime decision making, which is how we normally react. We make very rapid decisions based on having been there before in some manner, shape, or form. And we're usually very, very, very good at that. But when we fail, when that process fails, it can fail spectacularly. So, okay, so recognizing we can't be perfect at all, let's dig into some human-centered principles that can help pilots reduce errors and also make us more likely to catch them. And I'll try and be as specific as possible, and I like to start a discussion that will continue beyond this meeting to get very, very specific about what the problems are with procedures, specifically also equipment designs, what to do about them. So what do I mean by a human-centered principle? I don't mean to define it for everybody. I'm just going to float some things. I'd like to get your feedback on these things as well. But first of all, we need to minimize the spikes in workload, because we talked about the decrements of that. We need to give information to the pilot that's readily noticed, so it has to be a salient indicator or a salient thing that comes to be noticed and understood. And that's even when your attention is narrowed by workload and stress. Because we know things lock down, you only get a small focus on things. Whatever information is presented to the pilots has to blast through that. Similarly, we have to give our procedures and our equipment and displays the antidotes to the downsides of our cognitive biases. So since we lock into things, there's got to be something powerful to break us free of being locked in. Since we don't tend to see stuff we're not expecting, it's got to blast through that too. The human-centered principles have to accept that pilots are going to make errors and build in the safeguards that catch and correct the errors. And we need to build in procedures, equipments, and designs that keep both pilots in the active loop, mentally engaged in the control loop, in the flight dynamic loop, and in the environment externally and the threats that that's posing. And these things have to work in a kind of a generic way. And this is, one way I'd like to latch into what we had in the last panel where we talked about resilience, and that was kind of resilience of the pilot's minds and adaptability. I want to talk about resilience of procedures. In a sense, the procedures we give pilots to react to things have to work for a variety of things because the pilots may not know what's really going on. They don't have the information to know what's, that the rudder is jammed or whether it's a spoiler that's come loose. They don't know which. So whatever is happening, whatever response you give them has got to work for both of those things. So that's what I mean, in a sense, by a resilient procedure. Okay, so there's also a human-centered process that needs to be followed. And this has to go through all of these stages. We can't miss any of them. It's the design, human-centered, testing, human-centered, validated under realistic line conditions, not fake simulator conditions. And then, just as important, auditing the actual line results out there on the line, watching what's really happening to see how it's going. So that's what I consider to be a process of developing and maintaining these human-centered things. Okay, so now I want to try and be specific. Let's talk about workload spikes. So here's an example. A new ACARS system's put into the airplane. And to get an ATIS, which we do several times in every flight, you have to go through 4 keystrokes. It's down 3 menus, and it's on the second page of the 3rd menu. So that looks like a little thing, but to do all those keystrokes is taking your attention away from the other things that are going on. So if you could have that on the top level, since you're going to do that on multiple times per flight, wouldn't that be a good thing to have it be on 1 keystroke instead of 3 or 4 or 5? And sure enough, you might say, well, the monitoring pilot can just get the ATIS while the flying pilot's busy flying the airplane and watching it. But we're relying on the monitoring pilot just as much to be monitoring. And when they have to go do 4 keystrokes to get in the ATIS, they're not monitoring at that time either. So the system has broken down. So, it's just a tiny example, but this is what I'm talking about. We're avoiding the workload spikes. We can't avoid them completely because workload is workload, but we can try and minimize them by looking for them during the design phase of our procedures and then test them realistically and audit them, and we have to do all of these things. Another issue that we brought up already, and this is discussed extensively in the book that I wrote with Keita Smuke and Lucia Lukopoulos, The Limits of Expertise, is about the quality of the information. So if the information is perfect, we're probably going to get pretty good results out of the pilots. But if it's ambiguous or incomplete or worse, even wrong, people are probably going to follow that and make an error. It isn't really an error. It's their local rationality, like Decker says. They just, that's their reality at the time, is what information you give them. So I used to fly a plane that signaled engine failures by the low fuel pressure light coming on. And I used to teach in this airplane in the middle of the night at Midway Airport and we used to really shut down the engine, and we had no simulator. So anyways, how many times did the pilots pull out the checklist and start working the low fuel pressure procedure? And meanwhile, the airplane is yawing and rolling and everything like that. So a lot of times. So the signals you give people are really, really important. You're going to get what you give them. So even more so, the pilots are not going to reliably respond if an expected cue is missing. And this has come up in several accident investigations I've worked on where the stall warning system wasn't working and the airplane got slow and the stick shaker or the other stall warning didn't happen. And is it surprising that the pilots never realized the airplane was stalled? Yeah, they got other cues like the wings rolling 80 degrees side to side. But we train pilots that there's a stick shaker, and when the stick shaker fires off, you respond and you recover. If the stick shaker's gone, we're likely to do the wrong thing. So we got to be really, really careful not only with false positives, but negatives, and people are going to be misled by that. So we've talked about today the principles of good checklist design. You mentioned about the flap settings, cues and anchors. These are really, really important. And I want to just take a step from that riff a little bit and deviate from it a little bit and talk about error trapping and how they need to be, error traps need to be independent of each other. We're not going to get reliable information or we're not going to get reliable pilot responses as a whole system unless the things that are supposed to catch the errors are independent of the things that are causing the errors. And just as an example, a lot of airlines have the pilots do the takeoff performance data independently. So they use the sheets or whatever the company provides to calculate what they need, and then one pilot's supposed to input it in the flight management system, and the other pilot is supposed to independently check it. And so that's a good procedure. It has a nice independent backup. It fails a lot. Why does it fail? It seems so repetitious and duplicative. It's a waste of time. You're busy, you're trying to make an on-time departure. It's human nature to streamline those procedures and for one pilot to just say, okay, you got it in there, okay, I'll check yours. Or just check the other person's without ever doing it themselves. You see it happen again and again and again. So, the human-centered procedures design will recognize all of these tendencies and try and fight them. And you can't just tell people to do a good job. You can't tell them, okay, you got this performance data stuff, it's really important, so you just got to do it. And you can't even, tell them they're being unprofessional if they don't do it. There's usually reasons why we're deviating from procedures, and that needs to be looked into very carefully as a human-centered issue. Given the overall nature of things, we either need to keep humans completely in the loop or maybe take them out completely. When we're completely in the loop, we're getting all our information, we're reacting to the correct things, we're probably making the right responses, we're checking each other. If we're totally out of the loop, that means that the automation systems are reliable enough, we don't even need to be there. And therefore, any errors we might generate are impossible to, they don't have any effect. In my mind, we're in the middle ground right now where some things are automated and some things are taken out of our scan because they're, we're told that the automation's going to take care of that. So you need to worry about something else, but it's not reliable enough to count on. So in my mind, we're in the worst part of it. We're in the worst phase right now. We're in the middle. And so how do we do our human-centered design to keep people in the loop enough so that they can do their job? Okay, so one of the things that airlines are trying is to have pilots call out the flight mode enunciations. It's been used for years at some airlines. Some manufacturers have recommended it, some have not. Some airlines have not done it. Some have started. Okay, so you're supposed to call out the flight mode enunciation. So do they work? Does this work? Do they draw more attention of the pilot flying, the pilot monitoring, or both to what the automation is doing? In other words, if you tell the pilot that the airspeed is now controlled by the automation, the auto throttles are controlling speed, and we know that in some accidents recently, pilots have lost awareness of airspeed, and we think, well, okay, yeah, we told you that you could now pay attention to the weather radar because the automation's doing the airspeed, and now we're going to blame you when you lose track of the airspeed. Okay, so do the FMA callouts help deal with that problem? Do they help get us back in the loop of the automation? Or do these callouts just get to the point where pilots are parroting stuff and they're not even thinking about what they're saying and the other pilot isn't really listening? So does this actually work? I think that keeping pilots in the loop is the last, probably not the last great frontier of our work here. And it has to work almost perfectly when pilots are sitting there bored because nothing's happened for hours, and the autopilot's been doing a perfect job, and also when pilots are under stress from something unusual going on and they're going to have to be resilient and come up with something new. So I'd like to suggest and hope to hear some good discussion of that. And I'd also like to close by reiterating that not only do we need human-centered design of procedures and equipment, but we need to do that process. The whole thing is useless if we don't not only design it properly, but test it realistically, and then audit it to make sure it's working, and then be open to making changes. When I look out in the world, and what my experience has been over years and years and years, I've seen these breakdowns at all of those stages, and I've rarely seen it work smoothly and completely through. I hope that this process of this conference and the discussions we're touching off here today are going to help us make a lot of progress in that. Again, I'd like to thank the organizers and hope that we can see more conferences like this in the future.
Thank you, Captain Berman. I could listen to you all day. Thank you.
Thank you.
I particularly liked your point about procedural noncompliance and how if it's a repetitive problem with pilots, repeatedly making the same errors, the root cause could be that procedures are not human-centered to begin with. So that was a terrific point. Do you have any thoughts on human-centered SOP success stories?
Yeah, there's some great success stories out there. First of all, I think that the industry as a whole, ALPA, all of the players did a great job in the smoke, fire, and fumes process several years ago. And so what did we do? We worked together, we evaluated it from a human point of view, we realized that the old procedures weren't working, and just some of the key issues of putting, consider landing as soon as possible up near the top of the checklist. These are huge, huge improvements. Let's see, some other success stories were, there's one airline, like we said, there's a lot of airlines that have call-outs of the flight mode enunciators, and it's the job of one of the pilots, so usually the pilot flying is supposed to call those things out, and the other pilot is supposed to either say checked or verify it or supposed to pay attention to it. So, and it says if the first pilot doesn't do the call-out, the second pilot should. So in a sense, it made the call-outs both pilots' job, and when something's both people's jobs, sometimes it's neither person's job. So often there's a little bit of confusion. And one airline that I saw out there in the world is a British airline, actually defined in the SOP that it's the pilot flying's job to make that call out when the enunciation is boxed, so in other words, the first 5 or 10 seconds that it's been shown. And if it's not boxed, now it's the other person's job. So that gets both people into it a little more to watch and wait for their moment instead of to just say, well, all right, I'm not going to do it because he's going to do it. So I think these are tiny little changes, and we often talk about over-proceduralization, but this is a case where just a little bit more definition of the procedure it actually helps. It's a little unusual that way. Yeah.
Thank you very much. And Dr. Barshi, if you wouldn't mind giving us your thoughts. And I understand that you brought some data that supports the need for human-centered operating principles and procedures.
Yeah.
Great, fantastic. The floor is yours.
Yeah, thank you. Thanks, Helena, for having me, and thank you guys for being patient with me. Ben, taking the human completely out of the loop is not an option, not because we don't have the automation to do it, we do, but it only takes one human out of the loop, which is the pilot. It doesn't take the designer and the manufacturers and the maintainers and all these other people out of the loop. So all it does, it shifts the locus of error from the pointy edge to the blunt edge, but humans will still be part of the system. So unless we take all humans out of the loop, we probably not do that. So when Helena asked, when you asked me about the panel and you talked about implementing human-centered operating principles, I thought of a number of airlines that we've worked with and implemented human-centered procedures or human-centered operating principles, and thought about a different set of examples. But then I thought that for this meeting, it might be better to take a step back and look at a bigger picture. I could talk all day about other examples, and happy to talk with people during breaks and so forth if you want to hear some specific examples. But I thought I'll take a step back and look at some of the bigger picture and see if the technology works. Does it? Does it have to be pointed? Right, so when we think about human-centered operating principles, I think two key questions to ask is, what do we expect the humans to do? And what are they doing now? Is there a gap between our expectations and what they're doing now, and how do we address that gap? And again, there are lots of humans in the system, right? Humans design everything about the aviation system. They build everything about the aviation system. They maintain, they operate, they control. There are humans all over. And we can talk about human-centered operating principles for the maintenance hangar, for the cabin, for the office, for the gate agents. I mean, there are humans everywhere. Given the ALPA meeting and the pilot focus, let's look at the pilots and what do we expect the humans to do. And I stole this picture from Lance Sherry. Lance is the director of the Center for Air Transportation Systems Research at George Mason University, just out of town here. Excellent guy, an amazing mind, and people here, you don't know him, you should, and amazing resource. And Lance has been working for quite a while on that notion of functional complexity failures, where we see accidents like controlled flight into stall, where there's nothing seriously broken in the airplane, but there is some misunderstanding, some miscommunication somewhere in the system as a result of the complexity of the system that we designed. And we have a failure that is not just a simple, mechanical failure of something, but it's a system failure. And he says, when we look at certification, then we see that we have critical automation that has to be certified to 10 to the minus 9 reliability. And then we have essential automation that only has to be certified to 10 to the minus 5. So what we're saying is we're expecting the flight crew to mind the gap, to fill in between the 10 to the minus 5 to 10 to the minus 9. And one of those automation system that only needs to be designed to 10 to the minus 5 reliability is speed envelope protection. Air France 447, Asiana, we have all kinds of examples. Turkish Airlines in Amsterdam. We have actually a fairly long list of examples of that system failing, and then this is what we're expecting the pilots to do, to fill in that gap between 10 to the minus 5 to 10 to the minus 9. That's a pretty tall order. And so the question is, how well are they doing it, and how well do we support them? So I stole the next set of slides from John Holbrook, who is here in the room, and you should catch him during breaks because he has a lot of good stuff to say. John is our deputy for human factors at the NASA Engineering and Safety Center at Langley Air Force Base, which is Langley Research Center, which is only about 3 hours drive from here. So again, people in this area should take advantage. And he says, okay, let's look, let's have these 3 assumptions, right? Human error has been implicated in 70 to 80% of accident. We have data that shows that pilots intervene to manage aircraft malfunction on 20% of normal flights. And we have worldwide accident data that shows that we had during those 10 years between 2007 and 2016, 244 million departures with 388 accidents. Okay, so we have data. We have numbers we can work with. So let's think through this with this kind of a chart and put these assumptions in and start putting the numbers in. Okay, so we have human intervention, yes or no, accident or no accident in terms of the outcome. We have a total of 244 million flights, 388 accidents, 80% of accidents involve human error. How do we fit in the numbers? Okay, if 80% out of 388, then we have 310 accidents involving human error, 78 accidents not involving human error. We have 388 accidents out of 244 million flights, so we have 243,999,612. No accidents, right? And then we look at interventions on normal flights. 20% of flights involve crew intervention, so we have 48,799,922 flights in which crew intervened to solve a problem, right? So when we look at these numbers and the tremendous energy and effort that the industry and all of us have been putting into the question of how do we prevent the next error, or how do we solve that problem of human error, how do we design it out of the system, how do we design it back into the system in a roundabout way with unintended consequences. A number of people mentioned also on the previous panel, let's learn from what we're doing right. So in 310 flights, we had accidents in which, according to this, the crew was involved in 48,799,922 flights. We had a crew that saved the day, right? I think these numbers are helpful when we go back to the questions about how do we convince management to do something about human-centered. We have many, many more flights that are nicely done. Now, back to John's thought experiment, there are a few little problems with the assumptions that were the basis for these numbers. So one assumption is that human error has been indicated in 70 to 80% of accidents. Wrong. 100% of accidents are due to human limitations, not necessarily human error per se, but human limitations, right? When a fan blade decides to leave the hub and shatters the cowling on a Southwest flight, it wasn't the blade's fault, right? A human didn't design it right, maybe. A human didn't build it right, maybe. A human didn't select the material right, maybe. A human maybe didn't maintain it properly. A human maybe didn't inspect it properly. A human maybe didn't operate it properly. But it wasn't the blade's fault, right? 100% of accidents. It's time that we stop this nonsense of 60%, 80%, right? Just nonsense. So that assumption is wrong. Pilots intervene to manage aircraft malfunction on 20% of normal flights. Yeah, but pilots intervene on 100% of flights. Every day, every flight. And the intervention might be as simple as saying, you know what? It's a busy arrival. The box says that the top of descent is here. I'm going to ask for an early descent. That might be the intervention that makes the whole difference between a rushed, high-energy approach and a nicely paced approach that allows time to do everything. Pilots intervene 100% of flights. Right? And then, what counts as an accident, a hull loss, or a fatal accident or something? So even these numbers, how much was it? 49,999,000? Whatever. This is much too small a number compared to what is really happening there. And so the conclusion is, it's the humans who make the system work. It's the human that makes the system safe, reliable, resilient, efficient, whatever. It's the humans that make the system fail sometimes too, because it's the humans that make the system, right? And the whole system is there for people's sake, right? It's not for the sake of the airplanes. It's not for, it's for people's sake, right? We carry people from place to place, or we carry their goods from place to place. It's all about people. The whole system is all about people, right? So it's time we actually designed the system to support the people, all of them, all around. Thank you.
Thank you, Dr. Barshi. Insightful and thought-provoking as usual. Now we're sort of at the point where we want to start taking questions from the audience. So as you start making your way to the microphones, I'll start it off with a question for you, Dr. Barshi. And it sort of piggybacks on something Steve talked about, the 4 Ps. I know in your work in procedures development and such, you've talked a great deal about the 4 Ps. Any chance you could expand on that a little bit?
I could. Could I have the slides back? So when Steve said he was going to mention the 4 Ps, I thought maybe it's an opportunity to do a 4P primer. Just very quickly for the people who are not familiar. So the 4 Ps, like Steve mentions are practice, procedures, policy, and philosophy. And practice is what happens on the line. If we talk about the pilots, practice is what happens on the line. It's what you see as a LOSO observer, it's what you see as a line check airman, it's what you see in the sim as an instructor, is what you see when you look at your first officer or at your captain. It's what's happening on the line. That's the practice. That's what people do. Now, some people, are there any lawyers in the... I heard that there are actually only 2 lawyer jokes, and all the other are true stories. Anyway, some people would like you to believe, managers, lawyers sometimes, would like you to believe that we can contain all of practice within procedures. If we just write a procedure for it, it will be done properly. And we can write procedures for everything. And you can tell how long an airline has been in business by how thick the manual is, right? Because people have been writing procedures for everything. And that's impossible. It's a waste of time. And we can spend a lot of time talking about why it is a waste of time and why it is not a good thing to even try to do. And necessarily, some of practice is going to fall outside of procedures. So what we want is to have a set of policies that provide the guidance for that part of the practice that by necessity is going to fall outside of procedure. And it's going to fall outside of procedure because our imagination is limited. We cannot imagine all the possible situations people are going to be in. It's not possible because procedures are fixed and the practice is dynamic. Things change, okay? And you can tell that it's not possible to write procedures for everything when we have events of what we call malicious compliance, right? When employees decide to work to rule and do exactly everything by the book and everything grinds to a stop. Because the reason the operation works is that people violate procedures every day. Not because they're bad people, but because they're trying to get the job done and the procedures are in the way. So we want to have a set of policies that provide guidance for action in those situations where the practice falls outside of procedures. But policies are limited too. And so we're going to have some practice that falls outside of policies. It should be less and less of the practice that falls outside of the policies, but we will have some dark and stormy night somewhere where a crew is going to be faced in a situation for which there are no procedures and no policies. And this is where we want the overall operational philosophy to provide the guidance for how to make operational decisions when the practice falls outside of procedures and outside of policies. That's the role of the philosophy. Because when the practice falls outside of everything, that's when we have problems. And we can spend a lot more time talking about it if you'd like, but that's a quick notion of what the 4P framework is and how to think about it.
Thank you. Extremely educational. I see we have a text question available. If somebody could let us know what that is, and we'll take the mic.
All right. The text question. The text question is, when we speak of changing our culture to promote the concepts of modifying procedures to make them more human-centered and adding resilience training, how do we measure its benefits in order to resource it? There are a lot of competing forces, institutional, regulatory, et cetera, and finite resources to accomplish these goals. So metrics are needed to rack and stack the economics of the change. Any ideas on how we measure the benefit of these concepts?
Wow, that's about an hour-long answer, I think. But anybody want to take a quick crack at it? Ben or Steve?
I'll take a crack at it. That's a question that I run into all the time. So we're gonna execute this concept, but first, how can you demonstrate the validity of it? Well, I can, but it's going to cost you more than it's going to cost to implement the program. That's one of the things that drove me to the idea of all working together in a consortium, so that we can share those costs that just end up shutting down the conversation.
Yeah, I love this idea of a consortium. That's a fascinating concept. I'd sure like to see us develop that a little bit further. All right, Captain Dan Hamlin for our next question.
Thank you. We've talked about designing the best system possible. Please answer my question as though you're speaking to the Director of Procedures at Airline XYZ. The director's question. We know that some flight operating systems and SOPs and policies and philosophy are more resilient than others, sometimes after the fact. Where do I start to make sure my policies and procedures work with human strengths and ensure that they avoid human weaknesses? What is my next step?
I would say to that person, thank you for raising the question from your position, because you're in a position to make some change, and it's wonderful. And then next is this is going to be difficult because we have to get the organization to be willing to change. I mean, these things look like they're really okay because we don't have accidents every day, and so it's difficult to make the case that it has a payback, and it's difficult to get people to let go of the way we've always done things before. And so I would say the way to start is to start going through this process and convene some people together to look at the problem realistically. Find out what the line observations have been saying about some problem areas where things are causing distractions or some spikes of things. Look for a few issues, and then take that to your group, and then try making a change and see if you can smooth that thing out. And I think that this process could go very, very, very well. To be willing to look for trouble, look for it, and then do something about it. All difficult processes in the real world, I accept that, but things that could be done starting small, working together with other companies, and just start right now. Just take one thing and change that one procedure that's causing everybody to be distracted right at the time you extend the landing gear. I can tell you all about that one. Anyways.
Thank you. Fantastic. Any more audience questions?
Maybe I'll just, to Dan, the government label for my job is a research psychologist. And you know how many psychologists it takes to change a light bulb? It takes only one, but the light bulb really need to want to change.
Yeah.
Right.
Yeah.
Last question.
Thanks, Immanuel. Well, as we wrap up our time together, I just want to pose one question to each of you. What's step one for airlines when they want to embark on doing sort of a human-centric approach to procedures, policies, practice, philosophy, if you will? What's step one? Just a quick, if you don't mind, from each of you, thoughts on that.
To understand that you have the expertise, the data, and the information, and access to data already, if you'll approach looking for that information in a very disciplined, systematic way.
Ben?
I'll go along with all of those things that Steve has said and just say, there's people out there that know what the problems are within your organization. Let's just get started. Make a small victory and then go from there.
Immanuel?
Look at the previous slide and see my email address. Send me a note.
Fantastic. Well, please join me in thanking all of our panelists today.